Let us explore the properties of vectors. Here we are trying to understand commutative property of addition. The question here is, explain how the parallelogram law of addition can be helpful to explain the commutative property of addition. Well, let's say that we have two vectors. Let's say this is vector u and then we have a vector v. Correct? So we can add them using parallelogram. So to add them, we put them tail to tail. So we get vector u here, and then we put the tails together and we get vector v here. Now to complete the parallelogram, we draw this vector v so that the tail is on the head of vector u, and there you go. So that is vector v. And the resultant is, once you complete the parallelogram, let's say we will do that later, the resultant u plus v will be this, correct? That becomes u plus v. This is u, this is v, and that is u plus v for us, correct? So that is how we add vectors using parallelogram. But how about v plus u? If you have to do v plus u, then v you have here, put this vector u there, right? Tail aligned with the head of v. And so we get v here, v plus u. And where do you land? Your initial point is same, right? And the terminating point is also same, which was for u plus v. So we get the same vector as a resultant. So we see that u plus v is same as v plus u, correct? It's the same diagonal, which is from tail to the when vectors join together, opposite end of the diagonal of parallelogram, right? So with this we can prove commutative property of addition. That is, adding u first and then v is same as adding v first and then u, right? So that is how we can prove it. Thanks and all the best.